Okay. Should be in focus for you now. Yes, no?
Yep, it is.
Yes.
Before
Okay.
we begin this example, I just have one quick question about decoders.
Okay.
The 74138 we used in the lab, the 1 in 8, if I remember right.
Yep.
That has the G1 enable line, which is obviously to enable the whole thing for cascading or whatnot. But it's also got the active low G2A and G1A lines. What
G2A
exactly?
and G2B.
G2B, my mistake.
Yeah.
Why does it have two of these?
Well, because you saw when you cascade. Well, hang on to that question. It'll be explained right now.
Gotcha.
What do you want the domain to be? Your call, Kylie. You were asking about this.
Let's see. First of all, we could do.
The rest of your
0.
life doesn't depend on this. This is not like you're naming the naming your child.
I had to go back to see what kind of domain I'm even naming.
Well,
Okay, so
A B C D C A T S. I don't care.
Oh yeah,
Give me something.
CATS.
You want that?
Sure. I thought you were asking. Oh, I see. Okay, and then.
Now we're getting into what I think you were trying to ask, right?
Yeah.
Or trying to answer. Okay, what do you want to include?
We could do 0, 2, 5, 6, 7. Don't care. 10, 11. Don't care. 12 and 15. Don't care.
Okay, can we make 15 not a don't care?
Sure. I don't know. I'm just throwing numbers out, so you gotta correct them.
Let's make 15
harder?
not a don't care. I think it'll be fun. Okay, so decoders first, right, guys? Is that what you want to do first?
Sure.
Okay, so first thing, hey, with a decoder. Oh, I erased my my normal PDF Gaussian integral stuff. That makes me sad. Okay. You're going to see 138s throughout the rest of your life. At least I hope you do. Pretty popular chip. The decoder, and we've already seen that decoders can do a whole slew of things, right? So, we're going to implement this bad boy with a pair of 138s, right? So, the easiest thing to do is just cascade them. That means we're going to use 2, yes, no?
Yeah.
And I'm not going to worry about pin numbers, okay, guys?
You're good. Excuse me.
Not going to worry about pin numbers. So you've got the A, B, C select lines. You got, and as Brian mentioned, you got G1, which is active high. G2A. I was thinking A, I wrote B. And then G2B select lines. These two are active low.
Dude, I wish you would fucking figure out a way. Oh, sorry, not you. Oh my god, I didn't realize my mic was open. Somebody's playing a show really loud. I'm sorry, I thought my mic was muted.
Yes, someone owes a quarter to Pikachu. And Pikachu's kind of empty today because we had pizza last night.
I was trying to ask him to turn the show down.
You're fine. Was it who was that Carol?
-1.
Sure.
Was that Kylie?
Yeah.
I'll keep score.
Oh, come on. It's so hard. Oh, this isn't going to work. Okay. Here's your outputs. 0, 1, 2, 3, 4, 5, 6, 7. Okay? Those are your outs. Got it?
Yep.
Okay? And we got the same thing going on here, right?
Yes.
Okay. How do we do it, guys?
Isn't it with the decoder just as simple as like connecting them to what is the midterm?
Yes. But we have to enable them properly, right?
Right.
So, how do you want to do it? There are literally, 4 choices there? There are literally 4 factorial, which is 24? There's 24 different ways to do it. And actually, if you wanted to flip, well, whatever. Which variable, because the easiest thing to do is just take one of these variables and have that variable enable one decoder and disable the other one, depending on if it's a 0 or a 1. Which variable do you want to do that with?
Probably C.
C? Question or an answer?
Answer.
Let's do C.
We could do the S, and then one decoder would generate the even midterms and the other one would generate the odd midterms. That's always fun.
Sounds
Okay.
like it.
It becomes a matter of bookkeeping. That's all.
Right.
Do you want the top one to be do you want the top decoder, if we're using C, that's the most significant bit in the domain. So that's going to determine whether we're in 0 through 7 or midterms 8 through 15, right?
Yeah.
So do you want the top decoder to generate 0 to 7 or 8 through 15?
Let's do 0 to 7.
Okay, so what you just told me, is this Elijah?
Yeah.
Okay.
Plus 1.
I think that's plus 2 anyway. So if C is you said 0 to 7, right, Elijah?
Yeah.
Okay. So if C is off, we want this guy to be enabled. Yes, no?
Yes.
So that means that we need this. Does everybody see that?
Can you repeat that?
We're generating midterm 0 to 7, right? In the top guy.
Yeah.
The binary representation of 0 to 7. All of them start with a 0, right?
Correct.
The numbers 0 through 7, they all start with a 0. So that's why, and this is of course is C in our domain, the variable C. So if C is off, this guy is going to be enabled, which means that this guy is going to generate midterms 0 through 7. If we have a 1, on the other hand, in C's position, this implies that we're generating midterms 8 through midterm 15, right?
Right.
Yes.
Okay. So if it's on, we want this guy to be enabled, right?
Yeah.
So we can do this. We can invert it and run it in there, right? That'll work. Is that the best way of doing it?
Probably not.
You're not giving me much to go on, Elijah.
Probably
Do we
just
have?
connect it to G1, right?
You got it. You nailed it. You nailed it. G1 is active high. So if C is on, this guy will be enabled. Okay?
Okay,
So
I have a picture that was right on my lab. I just totally forgot it from a long time ago. in my diagram, G2A and G2B are wired together and connected to ground,
Okay.
as well as connected to that variable.
Do you remember why you had to do that?
No, I'm looking at this and I know I drew it and I remember drawing it, but I don't remember why.
Well, the 138, if you recall, and it seems like you don't, but that's okay. All of these enables, they all have to be active in order for the chip to do anything at all. Okay?
Mm-hmm.
So I kind of lied a little bit when I said, well, if we run C into G2A, that means this guy will generate 0 to 7. That's a little bit misleading because the other two enables have to be in their enabled state as well. So G1's active high, so what do we connect G1 to?
1.
1. Or VCC. G2B is active low, what do we connect it to?
Ground.
Excuse me,
So all
how do
three
you
of
know G1 is active high? I'm getting confused between active high and active low. Sorry about that.
Quite all right. That's on the data sheet. That's how the chip is designed.
Because stuff
Go on.
that's active low has a bar over it, right?
You got it.
Mhm.
So the G1 doesn't have a bar over, so that signifies that it's active low. Or, I'm sorry, active high. Did I answer your question now?
Yes, thanks.
Okay. So what do we tie these two? What do we do with these two guys, Kylie?
Ground.
I get a point for that.
So all three of the enable lines on each individual decoder must be active, be they active low or active high, for it to function.
You got it. Yeah, it's the enables are kind of like an and kind of thing. All right.
Right.
G1 has to be in its active state, and G2A has to be in G2B. It's not or where just one of them has to be. They all three have to be enabled. And somebody asked a question, I can't remember who, about why there's, I think maybe it was you, Brian, why there are two types of enables on this guy.
Well, not why there's two types. I can understand why there's a overall enable G1, and then why there's an active low if you want to set it up for cascading the way it is here. But why is there a G2A and a G2B, considering that we pretty much always just tie it to ground?
That's because we're dealing with very small, very simple kinds of implementations. Picture something that has, 100 devices, and only one guy can be active at a time. Well, you would cascade all sorts of these things. And that's when the multiple Gs come into play.
Why did we tie G2B to ground instead of to C again?
Oh, in other words, why didn't we just do this, right?
Yeah.
Well, do you remember when we talked about fan out? And
signal only can run to 5 things, I think.
That's the general rule of thumb, and that's what a lot of the data sheets say. So, what if C was already run to 3 other different devices? Okay.
And it might not work.
Yeah, I mean, if you start violating fan out, then nothing works. Tigger? No. This is Tigger. Okay. And he's interested in eating my dinner.
Baby cow would never.
Yeah, actually, he'd snatch a hamburger out of your hand and eat it in one gulp.
Oh, that's nice.
Baby cow would, definitely. Yep. Okay. Did we answer all the questions on this, guys?
Yes.
The
So
enamel
far, so
questions?
good.
Okay, so now it's time to make this bad boy work, right?
If I remember right,
Yes.
you just take every min term that isn't on the function and tie that to ground.
Well, we have to time out. Let's. We're forgetting something. What are we forgetting, guys? We're forgetting to connect the select lines, aren't we? And now Tigger's on my computer keyboard sending emails. Stop it. None of you had that problem, do you?
No.
Guys, we have select lines. Remember? What do we do with those?
Those get tied to the remaining terms in the function.
The remaining variables in the domain, right?
Yeah, that's what I meant.
I understand. So, go, Kylie.
Oh, I was just thinking out loud. Sorry. I was looking at my
apologize.
old diagram, and I was seeing like that I only had, because in this one it says A B C D, and I only had B C D tied to A B C, and I was like, where is the
Right.
C or the A? And I was like, oh, that was the outside.
That was out here, wasn't it?
Yeah. Yep. Yeah.
Yep.
Just
So, if you remember, guys, A is the least significant bit of the select lines. A is the least significant bit. Okay. So normally what you do is you tie the least significant bit in the domain, which is S, to the least significant bit in the select lines, just to make things simple. Okay. What should we tie B to?
T.
The next least significant one?
Which is?
T.
Isn't that T? What do we tie select input C to?
It's A.
There you go.
Is
Good
there
job,
any
guys.
reason why CBA is the order from most to least significant bit as opposed to ABC?
Yeah, I think I explained this when we were going through it. These devices are expandable, right? Somebody could come out tomorrow and say, you know what, this is a great device, but I can make it even better by making a 1 of 16 decoder. Okay, and by to do that, as a minimum, they would have to double the number of outputs, right? Instead of 8, we'd have 16, and we'd have to add a select line, right? Because we need 4 select lines if we have 16 outputs, right?
Right.
Does everybody see that? Well, if A is the least significant select line, then the progression to adding another select line is easy. You would just call it D, right? And D would be the new most significant select line. Does everybody see that?
Right.
Yes.
Now, if it were opposite, and A was the most significant select line, right? And that means C would be the least. Well, when you added another select line to expand the decoder, well, what letter precedes A? Can't do it.
okay.
So that's why when you see ABC, usually A is the least significant.
I just wanted to check really quick. Is this being recorded?
Oh, I don't know. Is it? Josh probably is not recording it. Let me. Oh man. I have the software. I just don't know how to upload. But Josh can talk me through it. You are? Okay, Esteban is cool. Thank you, Esteban. Okay, cool. Thank you. Thank you. So, did I explain why A is the least significant? Are we good?
Makes sense to me. Yep.
Okay. So now, with what we did, guys, this is min-term 0. This is min-term 7. This is min-term 8. And this down here is min-term 15. Okay? So now what do we do?
High all of our midterms too.
Okay. Which ones do we grab?
Isn't it all of them, right? Or do we not do we don't do the don't cares? That's right.
It makes no sense to include the don't cares, right? Because they'd just be another input. And we do an OR out here, don't we? Right?
Why is that?
We don't do an OR. What do we do?
Oh, okay, good. Because I have an and, yeah. I have an and I was confused.
You should have a NAND.
Oh, yeah, the little circle is an and, yeah.
Yeah. We have a NAND gate because this device produces active low outputs. I forgot to write the bubbles in. And I explained why that is the case as well, if you recall. All right.
Because a disconnected input tends to float high, right?
You got it. Yep. So we want high to be the disabled state. So we're going to grab min-term 0, right?
Mm-hmm.
What else are we going to grab?
2 and 5. And
Keep
6,
on going, Kylie.
6 and then 10, which is going to be 2.
This guy, right?
Yep.
This guy?
Yep. And then 12, which is 4. And then 15, which is 7, right?
Yep.
And then, so for the sake of this diagram, another thing I was confused about is because we drew all of the inputs, like there's like 6, 7 inputs going into the NAND gate. Like, is that allowed, or are we just doing it for?
Well, define the word allowed.
Would you accept
that
it on the
wouldn't
exam?
work.
Because obviously, they don't build
Yeah, they don't make
NAND
like
gates for that.
10
But
input NAND gate. Yeah.
at the same time, we can understand that to be an abstraction of some structure consisting of a number of NAND gates or equivalent combination of logic.
I would accept this on an opportunity. I would accept this. You would be incredibly hard pressed to find one of these bad boys out there in real life. Oh, that would be a good opportunity question.
What?
How would you create an 8? I've already created the opportunity, but I haven't created the final. How would you create an 8-input NAND gate?
Would you invert all of the inputs and then nest OR gates?
You could
that feed into other OR gates?
In fact, use De Morgan's, right?
Yeah.
There's probably half a dozen ways to easily do it. You could AND everything together and then use a NAND gate at the very end. You just can't cascade NAND gates like you do ANDs and ORs. So
wouldn't the AND gate not work because these are all active low?
Well,
then you would just put a NAND at the end, right?
Yeah.
Well, but if one of them was high for some reason, the output of the AND gate would still be
they're all going to be
low.
high, right? All of these are going to be high except for the selected output. Everything's going to be high.
Oh, right, yeah.
Okay. So if you did something like this, you have created a 4-input NAND gate. These are regular old ANDs, though. So you just expand that. That's one way of doing it. Like you said, you can do ORs. There's a lot of ways to do it. Yes. Yeah, there's a very good reason for it. Remember, disconnected inputs tend to float high.
One stupid question here. Every single thing going into that NAND gate is going to be 1, with the exception of 0, which is the active line.
Mm-hmm.
So, if it is one of the min terms that is actually going into that, as opposed to just one of the dead ones that's not connected.
Like this guy.
Yeah. If it was 4, every single one of those going in would be 1, which would be 0 going out because it's
Coming
a NAND
out.
gate.
Yep.
But if it was one of those, the NAND gate, no matter which one was selected, so long as it's one of the ones running into the NAND gate, the result will be 0, which is flipped to 1.
Yep.
Alright, just had to think through that.
That's exactly how it works. Any other questions?
The decoders were like kind of the easy part of it, honestly.
Yeah.
Now that I remember.
Yeah,
No,
yeah, they're pretty
not
easy.
involved in this one. This is
I'd
about
say
as complex as the decoder question will get on the opportunity, right?
Yeah. There's a more complex one, but I took it off.
So I don't know if this is asking too much, but in terms of that, would you kind of just ask us to like draw the connections, or is that not something I can ask?
What's that? What?
Like on the opportunity, would you ask us to just like draw the connections, or is that not something you can tell me right now?
No, you would draw this.
Okay.
Yeah.
Nice.
Yep. You ready to do this with a mux?
Yeah.
I guess.
Can we do this with just one of 8 decoder?
Yes, you can, but it's more tricky. And I have a question on you might see it on the final. You might see it on the final.
I do remember us only going through like 1 of 4s in class, and here, so I know that there's a 1 of 8 and a 1 of 16, right?
Multiplexer?
Mm-hmm.
Yeah, but there's 1 of 4, 1 of 8, 1 of
Those
16.
get
Yeah.
the when you do it like that though, the 1 of 8 and 1 of 16 are just simpler, right?
Oh,
Maybe?
much simpler. Yeah.
Okay.
But they cost more and they take up more space. So
will most
ready
likely
to,
probably be ST is the 1 of 4s.
Yep. You ready to do this with a 1 of 4?
Mm-hmm.
Absolutely.
Here we go. The 1 of 4, I think, is a 153. Is that right? I think.
I believe so.
We're not going to get bogged down in the enables and stuff like that, okay? So, so let's implement it with a 153, okay? And to start with, let's make it simple. How about CA as the select line? Sound good?
Mm-hmm. So when we say CA is the select line, that means that we're only using CA, like.
So what we're going to have, here's your mux,
Mm-hmm.
right? 4 inputs. Here's the selects. And what we're saying is that C is going in here and A is going in here. Okay?
Mm-hmm.
That's what we're saying with
Oh,
this
because you can
statement
only
right
have
here.
2 per mux.
Okay?
Mm-hmm.
T and S are going to feed into the expressions that we're going to connect up to I0 through I3. Okay? You guys ready to roll?
Alrighty.
Absolutely.
Who's taking computer architecture in the spring?
Me.
You the only one? Whoever you is? Whoever me is?
I'm taking it in the spring.
Okay. I think I'm teaching it in the spring.
I think you are. According to the schedule.
Who said that?
Elijah.
Elijah, okay. So when you saw my name on the schedule, you immediately asked for another section, right?
Totally.
That's what most people do. I absolutely love that class. Almost as much as this one.
AX is the Muxes Y, right?
I beg your pardon?
AX on that Mux is the output, right?
Yeah, this, believe it or not, this says output. This says out. Sorry. Okay, guys. Do you guys get a Karna map that looks like this? Did I screw anything up?
It looked good.
Is that good? That good?
Yeah.
Okay. So, we're saying that CA is the select lines, right?
Yep.
Yes.
So if C and A are both off, where are we on the Karna map?
Top row.
Top row, right? So we want I0 to be on wherever there's a 1 in the top row. Okay? Well,
that would be S naught.
That's what I get. I get an S naught out of this thing. And if you, and that would be just simply by doing this, right? That's the grouping.
In this case, would you mark where I0 through I3 are?
Absolutely. Yeah, sure,
and
Brian.
On the Mux itself, 1, 2, and 3 are I1, I2, and I3?
Yeah. This is I0. I2? Or I'm sorry, I1. Duh. Remember I2's down here, guys. And lastly, this is I3.
Could you explain why those one more time really quickly?
Sure. If C is off and A is off, where does that put us in the Karna map? Puts us in the top row.
Oh, okay. I got it. I think I get it.
So
okay.
I0 through I3 are permutations of C and A, which is to say 0, 0 through 1, 1.
Yes. Yep.
I'm just going to write that down because I remember Brooke explained it to me and I didn't understand until like lab. But so I0 is just basically 0, 0. I1 is 0, 1. I2, 1, 1, so on and so forth.
Yeah.
Okay. And I get it because that's literally 0, 1, 2, 3 in binary.
Yes.
Okay.
You got it, Kylie. You nailed it.
Thank you.
You're welcome. So, guys, what are we going to connect to I0? Somebody already said it. If you want to do it the Boolean algebra way, guys, this one right here, we already know C and A are off because we're in I0. We already know that. So this one is represented by T naught S naught. This one over here is represented by T S naught, which is right here. OR them together, what do you get? That's your I1, guys.
I0, you mean, or?
That's what I meant, Brian. Yes, I0.
So I0 through I3 are the individual rows of this K-map for the aforediscussed reason. And I0, for instance, there's only one group in that row, which, yeah, makes S naught. It's pretty conveniently put up. Once we get to, say, I2, or even an I1, where theoretically we could make a group between the don't care and the rightmost one in I2.
What would you do?
That's, I suppose, what I'm asking.
Well, we have a group here, don't we?
We do.
And we got a group here, don't we?
Yeah.
Are we done with I1? Are there any ones in this row that don't belong to one of these groups outlined in green?
There are not.
There are not. So therefore, I1 equals, what's this group right here? I get a T, right? Between these two guys. T is the only variable that doesn't change. Between these two variable min-terms right here, I think we get an S. So that's what I1's going to be. Do you guys see that?
Yep.
Mm-hmm. I2 is... Oh, no. I2 is also easy. I3, I guess, is the confusing one.
What's I2, guys?
2 is the bottom row, right?
Yes.
Okay. I'm just making sure because that's a little blurry.
That's a T, is it not?
Yeah.
And then we moved to I3. Man, we're doing so good, weren't we?
That's the one that trips me up. For starters, it's going to be some ugly Boolean stuff because, you know, there's a disconnected one. But we can make a group out of the rightmost one and the don't care directly above it. That, however...
You can't do that because you have to stay within I3.
Yeah.
Right. That's what I was asking, I suppose. Is it even possible to break out of those rows?
Nope.
Absolutely not, because that would mean that C and A change.
Right, right.
So I3 equals, what's the representation for this one right here that I'm pointing to?
T naught, S naught.
And how about this bad boy?
Yeah.
ES.
Guys, there's absolutely nothing you can do to simplify that.
We just gotta have a bunch of...
Yeah.
bunch of groups.
Yep. So I'm not even going to write, well, here, it's going to be an OR gate.
I don't know if I heard is this going to be another open book, open note opportunity?
Yes. Yes.
Okay.
What's the cost, guys? How many mux inputs do we have?
We have 4 inputs.
How many literals in the expressions do we have?
4.
1.
Oh, my bad. That's not
1, 2, 3, 4, 5, 6, 7, 8. How many gates?
Looks like
1, 2, 3, 4. I get 4 gates. Is that what you guys get?
yes, because
And that
and is
doesn't-
always
Inverters do not count.
I'm sorry?
Inverters don't count.
I would tell you if they do.
Okay.
In
Okay.
Lab 6, for instance, you specified that literals did count. Oh, inverters, my bad, did count.
Yeah.
And we don't count the 74153 itself. In
No,
that
because it's just
calculation.
there. It's just there. Someone told you to use it, so you're using it. It doesn't go against cost. Now, do you want to change the select lines and see if we can make things better?
yes. Real quick, I just missed. So there's 4 gates because we use 2 OR gates and 2 AND gates, right?
You got it.
And then what was that last 4?
This is 4 gates. There's 8 literals,
Mm-hmm.
and there's 4 mux inputs.
Oh, okay. Okay, that's right.
Does that
So
make
in
sense?
evaluating cost for a decoder or a mux implementation, you take a look at not just the circuit diagram, but whatever Boolean implementations are being
Are
supplied.
required. Yes.
Yeah.
Are required, yeah.
And you just add
Because
those.
yeah. I hope it's obvious to you that if, well, maybe not obvious, but if we change the select lines, we could make our life easier, or we could stay the same, or we could make our life more difficult. Let's figure it out, right? What do you say?
All right. One brief interlude before we do that, though.
Yes.
For the decoder example we just went over, there's 4 literals to that, right? Not really anything in the way of Boolean logic since there isn't a K-map. And then something like, 8 per gate, so 16.
I'm not going to give you any cost of decoder-based implementations. I'm not going to ask for that.
I ask because it's a specified question on Lab 6.
Okay. All right. What was the question? I don't remember.
Well, it just says supply cost for each and every one of the implementations, of which one
Okay.
is a
This
Linux
aimed
decoder.
far more at the mux stuff than the decoder implementation.
Right, so can I just disregard it for that one?
Yep.
Understood, thank you.
Okay. What do you want to change the select lines to, guys? Your show. This is your show.
Let's
Maybe
do...
you first.
Why not TNS, just to provide a lab-like contrast?
You guys game for that?
Absolutely.
Okay.
Sorry, I missed what?
TNS are the select lines now.
Okay.
You buy that, Kylie?
Yep.
So you still haven't delivered, huh, Kylie? Obviously.
Nope. I'm hoping I'll be able to take this exam and then not worry. But after that, I'll be fine. I just really want to get
Okay,
this out of the way.
You need to let me know if there's any problems.
Yeah, definitely. So far, it's fine. I went to the doctor today, and she said
Okay.
basically just waiting game.
I'm glad to hear that.
Yeah, I'm really hoping because if I can just have a nice weekend in the hospital and not really miss much, that would be great.
Yeah, there's something wrong with the statement. Have a nice weekend in the hospital.
Well, it'll be less
something that
stressful.
I understand.
I have one more week of labs too. I think next week is the last week of labs.
Yeah, next week. Yeah. Yep.
So
You should be able to finish up next week, right?
Yep, definitely. Yeah, we're about halfway through. Once we get to that point, because honestly, I just kind of want to go chronologically through basically through 6, 7, and 8. But
Okay.
for lab 8, I was only able to half finish the pre-lab because I was still a little confused. But we'll, when we get there.
Oh, it's going to be cleared up because we're going to do even more examples for you.
Oh, okay. On Monday and Wednesday.
Well, we're going to do them tonight.
Oh, okay, good. Okay.
Yeah, this Monday and Wednesday are this upcoming stuff is hamming.
Okay. Oh, I see.
Hamming codes, which is that'll blow your mind. If hamming codes don't send you into labor, nothing will.
Oh, I'm sure I'll be ready by then.
Okay. Guys, it's the same thing, only different, right, guys? Right?
Mm-hmm.
What size 0? Oh, God.
Quick second.
Size 0 is pretty ugly, isn't it?
Yes.
TS are the select lines, so they're not going to. You're only going to have C's and A's in the expressions.
Yeah, I was thinking out loud, trying to see my group. So it would be C naught A naught plus CA, right? Or no?
Right?
Oh yeah, okay.
What's I1?
Just
A not.
I think your dyslexia is acting up. I think it's C not A for I1. Isn't it C not A?
Definitely be my dyslexia.
All right.
okay. I know that obviously we should know how to do a KMAT by now, but I'm just so if the bit changes, then that means we omit that letter?
Oh, yeah, because it goes away.
Okay. Yeah, okay. Yeah.
Now we got I2, don't we? What do you guys see there?
Make that A.
Shout it out.
A.
Where do you get A?
So you have the 1, and then the don't care above that, you make that a 1.
Oh, no. We're on I2.
Oh, my bad.
Yeah. You're jumping to I3, which I agree with you, by the way. But let's do I2 first. Don't forget, guys, this is gray code, so I2 is on the far left hand or right hand side. So what's I2?
Is that C naught or with A naught?
That sure is what I get. Good job.
So for the purposes of the Boolean logic for each of the i's, you're pretending that they're basically 1/4 k-maps and completely ignoring TS here,
Yes,
right?
yes.
Because that was what was confusing me with I1. I was thinking, nothing changes there. It's 0, 1, 0, 1, so that should be not C, A, not T, S. But of course, it's its own k-map, basically.
Yes. What's I3? I3 is kind of interesting, isn't it, guys? We got 2 don't cares, and we got 1, 1.
Couldn't you do like C or A? Like you do one
You
or the other?
You could. So, okay, time out. When you said, do you mean this? C
No.
OR'd with A? Or it could be C, or it could be A. All by the
second
lonesome.
one. Yep. All by the lonesome.
I will totally 100% buy that. Who was that, by the way?
John.
John. Good job, John. Excellent job.
Which one should we declare it as?
Well, what do you think, guys? Technically, it doesn't matter because either one will get the job done, right?
Right. I mean, A is already used in its unmodified form twice in these Boolean expressions. C only once.
C is also used.
Which means we really could go either way.
Yes.
C
Do you see
in its
that?
not form is used slightly more often, but I don't think it matters.
It doesn't matter. It probably would not matter. It probably would not matter. If we had, if you have a choice, like we do here, guys, the best thing to do is go back through this stuff and see if anything can be reused, okay? Sometimes you'll have something like, well, it can be CA or it can be C naught A naught. Pretend. Okay? If we had a situation where you could choose this or you could choose that, well, oh, that's lousy. Here, we could do C naught A or C naught A naught. Pretend. Actually, that's a horrible thing too. How about C here? This is better. How about C A naught? So we could implement it with using this guy, or we could implement one of these I's using this guy. Which one would we choose?
Would it be C A naught?
Shout it out.
C A naught?
Well, look over here. Is either one of these products already generated? Is it already needed for something else?
C naught A naught is?
Yeah,
this guy is, right?
Mm-hmm.
Wouldn't we use this? It's already generated. It's already needed up here.
We don't want to add another, basically like a new thing.
Do you see that it would add to the cost if we chose the top one, right? Because we'd have another gate.
I'm sorry, but where are we getting these two from?
I just made them up, Brian.
Ah.
I just literally just made them up. There's not a C A naught term generated in any of these or needed for any of these. You got a CA, C naught A naught, C naught A, and that's it for products. All right. So, guys, what's the cost? Do you want me to draw the logic diagram, or do you think you can do that? You can do this, right?
Yeah.
You can do the logic diagram. Yes, no?
Mm-hmm.
I think.
The cost is 4 inputs, right? You got 4 I's. How many literals, guys?
9.
I get 9. Remember, we're choosing either C or we're choosing A. One or the other. We're not choosing both of them. How many gates?
Sure, I'm not going insane here. Every single repetition of any variable in all of the I's counts as a literal.
Yes.
Gotcha.
Well, to a point.
There are 5 gates in there, not counting inverters.
1, 2, 3, 4. I see 5 gates. So is this implementation better or worse than our first one?
It's a little... Oh, 4 plus 9 plus 5.
Can I arithmetic right? I think that's right.
Shouldn't that be 14?
It's 18.
No, it's
That's 18.
What am I even doing with that original 4? It's worse than the first one.
Yeah, it is. So we go with this one. Do you want to? What I'd like to do, guys, I'd like to change things up one more time and take a look at C and T as the select lines. Okay. Yeah. Yeah. Absolutely, you can do that, but you have to be careful. You have to make sure that you get the midterms placed in the right spots if you start messing around with this.
The rule regarding placement of eyes, then, is whichever the select lines are, in this case TS, the whole column that they occupy becomes one of those eyes.
Yes. Yes. Okay, guys. So if we choose, and by the way, I have no idea what we're going to end up with. Something not very pretty, but anyway, it's still doable.
Which one? CT as the...
Okay, guys?
All right.
Who else is taking assembly language next time around? Next semester?
I'm still in the process of finishing my next classes.
I see. Oh, I love assembly language. What can I get rid of, guys?
I'm good with the stuff on the left by now.
Can I erase the left-hand
You can get rid
side?
of all of it.
Does anybody want to take a screenshot right now and throw it on the chat? It's up to you. Just let me know if you're doing that.
I can.
I can do it real quick.
Okay, why don't you do that? That way, the worst that happens is we end up deleting it, right?
Someone beat me to it.
Okay.
They got it. You're good to wipe. The board.
Reboot the board. Okay, I'm going to bring the show up here, guys. Does anyone know when spring semester starts, by the way?
January 18th.
Rather, January 18th. Okay, that's 3 weeks. Yeah, I knew that, actually. That's 3 weeks out, okay. Should be interesting. Now, since I didn't jumble things up, guys, what that means is that, the ones and zeros and don't cares and all that, they stayed put. They didn't change. But with, what did we say? With our select lines being CT, the minterms associated with the I0, the I1, the I2, I3, those change, right? Right, guys?
Yep. So isn't I0 going to be that first, like those 4 top left squares?
Yes, it will.
Okay.
This is I0. Keep on going, Kylie. Where's I1?
And then I1 would be... Oh. It takes me a minute.
0, 1, right? Wherever in the
Yeah.
Carnot map, C is off, T is on.
So it would
Wouldn't it be here?
Where?
The top right.
Top right, right? C is off, T is on. So this is I1. Do you see that?
Mm-hmm.
Everybody?
Yeah.
Any hallelujahs?
I know. Excuse me. How do you know I1 gonna have C's off and T's on, like we suppose like that, or?
Oh, because I1, right? I1, the binary representation of 1 is 0, 1. So this is the value of C. The second bit is the value of T. So CT equals 0, 1. So you look in the Carnot map and see where that's true.
Oh, okay, gotcha. Thanks.
Does that make sense?
Yeah, definitely.
Okay, cool. Awesome. Where's I2, guys?
That's going to be in the bottom right, right? Bottom left, I should say.
Bottom left, yeah.
Or bottom right is I3's domain.
Yeah, it is.
Because I2 is wherever C is on and T is off, and then I3 is whenever both are on.
Yep. So, we have our own little fiefdoms here. I think that's a word.
It is.
So, we have our own little plots of land here, okay? Each one has 4 minterms in it. Of course, some of them are on, some are off. So, now it's time to figure out what I0 is. And I1 is, and so on, right? If you wish, okay, you can actually extract your own little K-map for each one. And it's easy when you're in squares. At least I hope you see that it's easy. Right? You're going to have a 1 in the upper left-hand corner, a 1 in the lower left-hand corner. The question is, what specifies the rows? What specifies the columns? Well, we know that CT already taken care of with the select lines. So the only variables left are A and S. Well, A is off in the top row and on in the bottom row. So we can do that, right? Right,
so
guys?
A and S kind of just stick to whichever side of the diagonal arrow they were originally on.
So A follows 0, 1, right? What's S? S is off.
0, 1.
S is off for the left column. It's on for the right column. So if it's easier for you to do it this way, rather than to look at the big picture, feel free to do that, guys. That's okay. What's I0? This is the ugly one, is it not?
Yeah, that is A not S not R with AS.
That's exactly what I get. Okay? Everybody good with that?
Yes.
Absolutely not. No. Nope. Whenever you have the diagonal situation, what you do is you say, oh, man, and move on, okay? Because there's nothing you can do about it. Okay, let's extract I1, okay? Once again, we're going to have a 4 4 square kernel map, 2 variable. I think it makes sense to stick with just A. Well, we don't have a choice. We have to stick with A and S. And we're going to have this guy, and this guy. Yes, no?
All right.
We have a 0 in the upper left-hand corner, guys. Yes, no?
We do.
Everybody see that?
Yep.
Yes.
Okay. A is off in the top row. It's on in the bottom row, right? S is off in the left column and on in the right column.
Yep.
Is that true? Everybody with me?
Yep.
And it's pretty obvious here that there's only the one group we can make out of this. No reason to make the don't care a one.
Mm-hmm. There's a major problem with what I just did, guys.
We should
Did anybody
switch the 0 and the 1.
Shout it out?
Switch
one at
the
a time,
0
please.
The 0 and the 1 should be switched.
Great.
Who said that? Who said that?
It's a lot.
Oh, Talal?
Yep.
Good job. Guys, do you see that the S is a 1 in the leftmost column and a 0 in the rightmost column? You have to pay attention to that.
And the
Okay.
same should go for 3, right?
Yes.
When we get to that.
When we get there, yeah. Okay? You just have to notice that. That's all, guys. So how do we group the ones so we include all the ones? We have a don't care to help us out if needed. So how do we do that, guys?
S not?
So you're saying what? Group these two?
Yes.
Is that what you're saying?
Oh
Yes.
wait, I'm a little confused on why do we switch those numbers?
These two?
Yeah, yep.
Come up here. In I1, which is the third and fourth columns, right?
Oh, it's 1. Okay.
1
The
here.
first number is 1.
Yeah.
Okay.
That was Kylie, right?
Yep.
I get a point for that, by the way. So what does I1 equal, guys? Somebody already said it.
That's not.
Good job. Excellent job, actually.
So with
I have
all
a
these
question.
One at a time. Go on.
So for I1, when it's S not, would that be contained in I1, or would it not go in I3?
We haven't even reached I3 yet.
Okay.
So what we're gonna, can I erase this side, guys? We're done with this, right?
Yep.
It's also posted in the chat, is it not? You guys said? Somebody took a picture and posted it, right?
Yes.
Yes.
So for this, we don't ever include don't cares in our.
No, we do. We do when we want to, when they help us out. We ignore them when they don't.
I see.
Okay? Yeah, think of it as the annoying friend that you have that sometimes, is of value to you. That's
They have a
probably a
Costco
horrible.
membership.
That's probably a horrible analogy, but anyway. They are. They are. That's exactly what they are. It's probably a bit more socially acceptable than using a friend when you want to and ignoring them when you don't.
Let me see what kind of friend you are.
I don't have any friends, Kylie. What are you talking
Well,
about?
that's why.
Uh-huh.
You have baby cow.
That's why I have baby cow, because I don't have friends. Yeah. Baby cow's awesome. He's totally awesome. So, guys, do you see that we're just going to do one of these numbers for I1? Do you see that, guys?
Can we
Yeah,
still
it's
just
the
draw
same
it
story
as?
as before.
Can we?
What's that, Kylie?
Could we still just draw it as like a line to S naught, or do you want us to connect it like that?
I don't care how you do it. Either way is acceptable.
Okay.
Okay, but if you were going to wire it, right? If you're going to wire this thing up, wouldn't you do this?
Yeah.
So, anyway. All right. Ready for I2, guys?
Alrighty.
I have got to
And
clean
that's
my
going to
office
be
up.
0 and 1 on the top and 1 and 0 on the side.
Good job, Brian.
Because this is really just a chunk, the lower left chunk of the K map, ignoring C and T.
That's exactly what it is. That's exactly what it is. Do you see why we have to flip A? The values for A? Do you see that? A is on for the top row, and it's off for the bottom row.
I
for
wouldn't
I2.
even describe it as flipping it. It's more like you're just carving that chunk off of the K map.
Okay, well, yeah.
Mhm.
Yes, yes. Do you see why it's however you want to phrase it? Do you see why it's 1 0 instead of 0 1?
Yep.
Does anyone not see that? That's the most important question. Excuse me. I get that. And that's it. Are there any dissenters?
Nope.
Nope.
There's nothing we can do, right? Right, guys?
That'll just be 1 0, that is A, not S.
Boy, it's too bad it wasn't A not S not, because then we could have just grabbed this output, right? And run it straight into I2. That would have saved a gate. And its literals. Oh well, such is life. Okay, how about I3, guys?
Wouldn't it be 1 0 and then 1 0?
You got it, Kylie.
And this time we do include the don't care because it helps us.
You tell me what we're going to do.
I was.
And I think you were. So I think what you said was do this.
Yep.
And then we got to do this to grab this one, right?
Mm-hmm.
See, if we had a don't care up when we did I0, if we had a don't care in one of these guys instead of zeros, we could have done the same thing and made it a whole lot simpler. But again, such is life, right? Right, guys? So I3, what's I3, guys?
That's going to be S plus not A.
S ORed with not A, right? Good job, guys. What's the cost?
9 literals, 4 inputs, 5 gates. Identical to before, it's 18.
Yeah, I'm not surprised. So we got 4 plus, you said 9?
Yes.
Did everybody else get 9? 1, 2, 3, 4, 5 gates. Okay. That's what we got, guys. No. Yes. Yes, but it'd be better than implementing it just out of straight Boolean logic. Okay, you could have a 5 variable map like we did with Quine McCluskey, right? And you could implement it with a 1 of 4. Okay. You could have 2 of the variables be the select lines with a 1 of 4. And each one of these could have a function of 3 Boolean variables instead of just 2. Okay. You could. Well, if you had like a 5 variable, I would think you would strongly take a look at the 1 of 8 mux. If you were doing that, take a look at that, right? Because then, yes, you have double the inputs, but guess what? Each one of those inputs is just going to be a 2 variable Boolean function instead of 3. Those 3 variable Boolean functions can get nasty. Those of you that are doing the figured out the expressions for the sequencer lab, you already know that. Oh, absolutely. And guess what you're going to do tomorrow? But I really can't say any more than that, okay?
So from the meta perspective, we've done 3 different here with 2 paired lines, one using the first half of the domain, one using the second half.
Nope.
Is there a general rule
Nope.
as to... Gotcha.
Nope. I was thinking if we did A and S as the select lines, we would have the 4 corners. That would be I0. And then you'd have these 2 guys. It was looking pretty good. If you have these 2 guys for I1, or I'm sorry, these 4 minterms for I1, I1 just equals 0, right? Because you'd ignore the don't care. Do you want me to write it out for you? Talk to me.
I think for time purposes, it might be best if we started moving on past multiplexer problems.
Makes pretty good sense to me now.
Okay, I'm going to just write the Carnot map so you can see what you would have to do. Nothing more, okay? Because I'm sensing like some confusion. So if A and S were the select lines, okay? Okay? In the Carnot map, guys, I have to put the 0s and 1s, don't I? What am I doing? And if you don't like it, you can blame Kylie. Right?
What?
You're the one that selected the minterms, if I'm not mistaken. So, if A and S are both off, guys, we're in the 4 corners. And that's going to be I0. Okay? I1 is these 2 paired with these 2. Okay? I2 is these 2 paired with these 2. I hope it's obvious to you that I2's going to be a bear because we would have the diagonals. And lastly, this is I3. I3 is not too bad. It's just an OR gate.
All right, so okay, I3 is the center for. Could you show again where I0 through I2 are?
I0 is selected if A and S are both 0, correct?
Yes.
Okay, so where is A0? A is 0 for the top row and the bottom row.
Right.
Where is S0? Left column, right column.
Mm-hmm. So it's going to occupy the four corners of the map.
Four corners, that's I0. Yep. Where's I1? Well, I1's selected if A is off still and S is on. So where does that happen? Well, A is off for top row, bottom row. A is off for top row, bottom row. S is on for the middle two columns. So that's why this wraparound is I0. I'm sorry, I1. Do you buy that?
And the remaining space, by process of elimination, must be I2.
Yep.
That is a terrible set of eyes.
I have a question.
Go.
What would I1 equate to? Because it just has a don't care in it.
Well, wouldn't it be best to just set it to 0?
Yeah.
If you made the midterm 1, if you made the don't care 1, you would have to use an AND gate to get this guy, right?
Mm-hmm.
And we don't need it, so I1 0. If you're interested, I0 would be C0 ORed with T. I2 is nasty. It's C T0 ORed with C0 T. I3 is just an OR gate, right, guys? Just an OR gate. Do this and this. And I get C0 ORed with T. So on the surface, this looks like it's not any more advantageous than any other of the implementations, right? This helps, but this hurts. But there's one very, very important thing that you need to notice. What is it?
Can't we combine
Shout it out.
I2?
I2 can't be combined with anything. This is I2. Let me rewrite this.
We could theoretically rewrite I2 as a single, 2x2 square, right? With the appropriate numbers. In which case it would be a diagonal still.
It would be. What's I0? C0 ORed with T. I1 equals 0. I2 equals C T0 ORed with C0 T. What's I3? That's equal to C0 ORed with T there. That's a lot easier for you to follow, I would think. So if
I0 and I3 have the same.
Shout it out, Kylie.
I0 and I3 have the same terms.
I0 equals I3. Okay? So we just need, if we're implementing this, right? Can I get rid of our implementation up here? Because that was based on.
Yep.
Okay. So what we would end up with, guys? Yeah, this is time well spent because we ran into a situation that we haven't seen before. What's I0, guys? How do we generate I0? Don't we need an OR gate? Yes, no?
Yep.
C naught and T. Yes, no? Everybody?
Yes.
Mm-hmm.
But see what we can do?
We don't need to have two of them. So
Yes.
we're just
Yes.
gonna
We know I1's 0. That doesn't raise the cost any. This one does, right? I forget what we have. C T naught C T naught. And this is C naught T. And this is an AND gate. Oh, come on. My bad. I'm sorry, guys. I got my ands and ors flipped. There we go. So this is T naught up here. C T naught, C naught T. Or together going into I2, right? What's the cost? I'll spot you the 4 because we still have 4 mux inputs, no matter what. How many literals? Well, 1, 2, 3, 4, 5, 6. This does not count because it's not a literal. Do you guys get 6?
All
Yes,
right.
no? 6 literals, right? How many gates, guys?
4.
Isn't that the lowest cost we found so far?
Mhm.
So sometimes it pays to keep on digging. Are there any questions?
On the opportunity, will we be asked to identify the lowest cost approach to a mux?
Yep.
Okay.
It's a fair
But
question.
in the sense of being given a set, like, implement it with CT, then implement it with AS, etc., and then being asked to...
Take a look at the costs of each implementation. Yep.
Or are we just going to be left to go through every permutation and see which one is?
Brian, I wouldn't ask you guys to do that because that's a... some of you are probably complaining about the amount of busy work that you have now. I mean, it's all part of engineering, but no, I'm not going to ask you to go through all 12 permutations. I'm not going to ask that.
I have a question. Yeah.
Yes, sir.
I heard that Kylie is like in the hospital getting ready to give birth. Is that true?
Yeah. No, I'm not in the hospital, but I'm gonna be soon.
Wait, is she going tomorrow? Wait, say that again. Hold on.
No,
Guys,
not
you
yet.
realize this is none of our business, right?
Oh, well, I was just going to say, you are a legend, just by the way. You have my admiration. You are awesome. Carry on. That is all.
Thank you.
Is that Kyle Winborn, by the way?
No, this is Josh. I'm on the Sun Lab Discord.
Oh, all right. All right.
I got Grant and I got
Kylie is a legend. Kylie is a legend, and yes, she will be remembered. She will totally be remembered.
I was just going to say, that's just amazing. So that's all.
Well, thank you.
Kylie's going to be doing carno maps in the delivery room, okay?
I probably would. It might distract me from the pain.
Uh-huh. The nurses are going like, push, and Kyla's, no, I'm not. I haven't figured this out yet.
Yeah, something like that.
I have to find out what I3 is. Leave me alone. You guys ready for sequencers?
I have a question about the cost.
Yeah.
So if you connected, so there's a C NOT at the top with the OR gate, and then there's a C NOT at the bottom with the AND gate.
Yeah.
If you connected one of the C NOTs to the other one, would that
It doesn't affect cost. It does not affect cost.
Okay.
They still count twice. One, 2, 3, 4, 5, 6. You got 6 literals. And guys, there's a reason for that. Okay? Each and every one of these gates requires power and it requires space. It also has timing implications, but we don't need to worry about that. But they do require power, so that's why when we use a literal coming into a variable coming into a gate, that's why we count it as part of the cost. This does not count because theoretically we can ground as many things as we want, and that doesn't count against power draw. Okay, that's why that is. That's why we count. We got a T here and a T here. So yeah, they come from the same variable, but they go to 2 different places. So we have a cost of 2 because of that. Yes. Yeah. Yep.
So if that 0 was a 1 instead, would that count, or would that still not count?
Nope. It would not count. Remember what the definition of a literal is, right? The appearance of a variable or its complement. Okay? 0 is ground. That's not a variable. 1 is VCC. That's not a variable either. Okay? Well, it'd be drawn power from the power supply. It'd be drawn a little bit, but we ignore that because that's just a power supply sizing. However, whatever's generating T, that doesn't have infinite power, right? That's a gate, theoretically. That'd be a gate. They don't have infinite output capability. Okay? Did I answer all your questions, guys?
Yeah.
Okay. Ready for sequencers?
Yep. I'm gonna step away for just 1 second, just so you know.
Will we have questions centric to just latches and flip-flops before we move on to sequencer questions?
Yeah, sure. Can I reboot the board though? Yes, no?
Sounds good to me.
You guys are too quiet. You need to talk more. How many teachers have told you that?
Only you, I guess.
You need to talk more. See, I'm going to let you in on a little secret. You guys are my entertainment. Okay? Well, I don't have a choice, but anyway. Okay, Brian, what are your general everyday questions about flip-flops?
Alright, I'll start with the stupid ones.
I doubt they're stupid.
Can you go over again the fundamental difference between a
Latch and
latch
flip-flop?
and a flip-flop? Yeah.
A latch holds information as long as power is applied. And the inputs don't change. A flip-flop is basically, in a nutshell, it's a latch with a synchronizing signal, also known as a clock. Okay?
All right.
Now, a couple other... Go on.
I'm sorry, go on.
No, ask your question.
Is an SR set up a flip-flop or a latch?
The way we introduced SRs, they are latches because they don't have a synchronizing clock. Talk about the NOR gate based and the NAND gate based, right?
I believe we did.
Mm-hmm.
Have to check back in my notes for that. Will we be asked to implement the both of these on the opportunity?
Know how they work, right? You got it in your notes, so it's fair game.
Both the NAND and NOR implementations?
Yeah, it's fair game, yeah.
Can we go over that again?
Sure. I don't have my notes open, so you guys are going to have to help me out. This is the active low implementation, right? And let's see. If this is low, that's low, that's going to be high. So this would be... Is this what we did? I can't remember.
Where did I put my page on SRs?
I don't know.
That looks right.
The NOR implementation looks like this. I don't know if I have the inputs connected to the right spots. I don't know. I might have them flipped.
No, that's
What's
right.
the difference between R and S?
Is this right? Was that John? Is this right?
That's for the active low RS flip-flop, yeah.
Yeah, active low. This is going to be for the active high, the NOR gate implementation, right?
Yep.
Was that a yep or nope?
Yes.
Thank you. So this time we have S up here, right? No, we don't. We have R up here and S down here, right?
Yeah.
This is active high. This is active low. Okay. And these are, they're in your notes, okay? and whatever's in your notes is correct. The most important thing about the SRs, guys, isn't how they're connected. I'm not going to ask you to memorize stuff, remember? I'm not into that, okay? But what you do need to know is that is the reason why, in general, we prefer not to use SR latches. Do you remember what the reason is?
I do not.
Is it like switch bounce or something?
Kind of. They have an invalid state. So with the active low, it's when both S and R are low. And if S and R are both low, both of these guys are going to be high. That's a violation, right? Because Q and Q not have to be opposites. Right?
Mm-hmm.
Would it be the same if R and S were high for the active low?
No. If they're high, then, and remember we did this on the board, if they're both high, the inputs are inactive and Q and Q naught don't change. That's the no change state. Do you remember doing that on the board?
I do. Just looks like I misplaced that page.
Okay,
so,
that's fine. No problem.
Yeah. And the same goes for active high if R and S are 1?
Yes.
In other words, if both are active at the same time?
Yes. If they're both high, what happens to the circuit, guys? If we have a 1 on R and a 1 on S, we'd have a 1 coming out of the OR gate, which gets flipped to a 0. We'd have a 1 here, which gets flipped to a 0. So both outputs would be off. And again, that's a violation of the flip-flop rules.
Right.
Okay.
Is there any difference between SR and RS? Because it should be symmetrical.
No. There's no difference. Okay. Now,
then why the circle to the left has the R naught and S naught, while the one in the right has the R and the S?
Because they're active high. The line is just signifying that this signal has to be low to be active. Okay, that's what the complements mean.
Okay, so the right one will be the signal have to be high to be active?
High to be active. Yeah, you got it. You nailed it. Good job. Okay. Flip-flop basics. Does anyone else have any questions on this stuff? Because we can review the basic types of flip-flops and types of triggering next, if you wish. I beg your pardon? I'm sorry? I was coughing. I didn't hear. I'm sorry. Can you repeat that? Yeah, most of the time, and you've seen this in lab, right? In regular flip-flop design, if you've got Q, you've got Q naught. They're both available. And in the sequencer circuits, if you, I assume you've gotten that far, your expressions involve, half of the expressions use an inverse of one of the Qs instead of the uncomplemented, right? You got just as many Q0 inverses as you got Q0s. So that's why they're available to us. Does that make sense? Yeah. Yes. Yeah, the only time that's different is if, and I'm gonna prepare a little summary of memory structures because we're not gonna have enough time to lecture on it. But if you have a memory structure where you're storing, like a byte, 8 bits, well, that's simply 8D flip-flops. And if it's a full value, then usually you're not interested in the Q naughts. You just want the Qs. So that's an example of not having the Q naughts. Yeah, if you're storing memory, you're not going to be using Q naughts. Okay, you guys ready to look at Ds and Ts and JKs and all that?
Let's go.
Yes.
Ready to roll?
Yes.
Here we go.
Wait. Oh, damn it. I was going to say, what does that say at the top?
What did it say? Latches?
No, you don't have to write it again.
It said latch holds info as long as power is applied to the inputs, and the inputs don't change.
Okay.
All right.
Yep. So it said latches hold info as long as power doesn't change.
As long as power is applied and the inputs don't force a change.
Okay.
Does that make sense?
Mm-hmm.
They don't have a synchronizing signal like a clock. Do you see, and I hope it's totally obvious to everyone, both of these are latches, right?
Mm-hmm.
There's no clock. All right?
Mm-hmm.
Okay. Can I erase it now without getting chewed out?
Yes.
Yes, no?
Yep.
All right.
Sorry, I had to just had to step away, so I missed. But I'm pretty sure I understand the active low, active high.
I know you do. I know you do. I know you do. Okay. What's a D flip-flop?
Well, I remember it stands for data.
How many inputs? How many inputs?
Is it 2?
Try again. Just the D input.
Yeah.
Oh, yeah.
It's got D, Q, and Q naught, and also an enable signal, right?
Yeah, we're getting to that, Brian. As soon as I said how many inputs, you could easily answer like 3 or 4 if you're including preset, clear, and clock. And obviously Q and Q naught outputs. In a nutshell, what would you tell your significant other what a D flip-flop is? What it's used for, how it works,
Jared, do you know
its
what a D
operation.
flip-flop is? Do you know what a D flip-flop is? Did you learn that? A what? A D flip-flop? No, you don't.
What's a D flip-flop? We have to help Kylie out.
Oh. I'm sorry.
What's a D flip-flop, guys?
He says, does it
What's
reverse
it
the
used
thing that you
for?
put into it?
It stores a single bit. That's what it's used for. stores a single bit of info.
Right?
No, you're wrong.
Two.
Stores a single bit of info.
What the fuck?
He owes a quarter. Tell him he owes a quarter, Kylie.
The first time was open mic. The second time, I didn't expect him to do that.
It stores that's what it's used for, guys. The D can't toggle, right? It doesn't have a set state. It doesn't have a reset state, like a JK, for example. It just stores data, right? And the characteristic equation is simply that Q next equals whatever D is. Remember that?
Yep.
That's the characteristic equation for a D. So whatever the value of D is on the active edge of the clock, that's what's going to be, we call it clocking into the flip-flop. That's what's going to be clocked in. Okay? Does that make sense, guys?
All right, so
yes.
Q is the present state, right?
Well, it's the output.
Right.
You didn't say it was Q old. You didn't say it was Q next. So I don't know, if it was the previous value of Q or if it was the next value of Q. So I don't know, but it is the output, Brian.
So the next output it'll give out is just whatever D is right now.
You got it. Yep.
So in a very basic sense, this thing like epitomizes a flip-flop, right? It's got something that it holds info for, and it can output that info or change it. Where does the clock signal factor into this?
Well, if we do a timing diagram, right? We did a timing diagram, didn't we?
Mm-hmm.
So here's our clock. Normally, clock is a periodic waveform, right?
Mm-hmm.
And here's D, okay? So if it's a rising edge triggered device, which they usually, most of the time you see rising edge versus falling edge. You see more rising edge than falling edge. So if D goes high here, and then low, and then high. If we have something like this, what does Q look like?
Well, if Q's next is going to be D, then I guess it should trail behind... No, it should be equal to D, right?
Q equals D when the active edge occurs, okay? So we have an active edge here, don't we? What's the value of D when that active edge hits?
1.
1. So Q equals 1 during this time span. And it stays 1 until we get another edge. What is Q in this area here during this time here?
Isn't it like we don't know?
Yes. It's the I don't know state. Okay? All right.
Okay.
What's D here, guys?
Q is going to stay at its current level because at the current clock pulse... No, my bad. It's going to go down to 0.
Does everybody see that?
Sorry, I'm getting a little confused. Can you explain again this part?
Absolutely.
Yeah.
Q equals D the value of D when the active edge of the clock occurs. So we said it's a rising edge triggered device. Okay. So every rising edge, you can think of it as every rising edge, whatever value D is, gets transferred to Q. Does that make sense? Guys, help me out.
Yep.
Can you
That's
go
why.
over a pulse triggered one next?
Sure. Yep. So it's only on the active edge do things change. Okay, guys? Well, yeah, Q equals. Yeah. Okay. So when this clock edge hit, when this clock edge occurred, D was high. That's why Q goes high. What about when this clock edge occurs? What's the value of D?
It's low.
So what does Q do?
We're low.
Very good. Good job. Now, we got something interesting going on here. We got a little pulse on D, right?
Yep.
Does that affect Q at all?
No.
It doesn't. Very good. It doesn't because we don't have an active edge of the clock during this pulse on D. We don't have an active edge. This pulse is completely and totally ignored. Okay? So then we come to another edge. What does Q do? Sorry.
Well,
What's
Stay the
Q?
same.
0.
Stays the same. Good job.
So in very simple terms, the clock pulse governs when the flip-flop actually looks at D, and whatever D is at that instant, it sets Q to.
Yep.
And that's what the purpose of the clock pulse is for a flip-flop. It permits a flip-flop to continuously update itself according to some input signal, whereas a latch needs discrete updates, as if it was being like fed by a switch to change its inputs.
Yeah, the latch doesn't wait around for an active edge, right? The latch would change its output immediately if the inputs caused a change. Okay? Does that make sense? Talk to me, guys. Yes, it does. Yes, it does. Yes, it does. Yes, it does. Yep. It's got the edge detection circuitry. Okay. Now, do you want to talk preset and clear?
Sure thing.
Yes.
You can see that, right, guys?
Yeah.
Okay. Let's do a timing diagram. AD flip-flop. Rising edge triggered, right? Make things simple.
So basically, real quick, in terms of like the clock and the D, I heard the summary. It kind of made it a little better, but so why do we ignore like that one rising edge, the second rising edge in D?
In D, this guy.
It's because of the clock, right? But why?
Yes, exactly. It's because of when it occurs. Okay.
So because it doesn't occur when the clock has a rising edge?
That's exactly what's going on.
Okay.
Did I answer your question?
Mm-hmm.
Sorry, guys. My knee's killing me today, so I gotta kind of take a break. Okay. Okay, big timing diagram, guys. What do we need? We need clock. We need D. We need a better marker. Here it is. Nope. Okay. Now, the clock's going to do this, guys. Can I get rid of our previous timing diagram, guys?
Yep.
Can I get rid of this?
Yep.
We got any Tigers fans online? Nobody's a Tigers fan, really? All of you get Fs. Really? That's horribly unfortunate. Okay.
I'm a big Guardians guy.
Guardians? Is that like Guardians of the Galaxy or like Guardians of...
It's definitely a different name if you ask me.
The Cleveland Indians changed their name to the Guardians.
Yes, they did. Which I can't stay in Cleveland, so I just make fun of them even more than I normally do.
Oh, that's sad.
That's Kylie, right?
Yeah.
Have you ever been to a Browns game? Cleveland Browns?
No. Nope.
Okay. Has
I
anyone
did when
been?
I went 0-16.
Did you sit in the dog pound?
I've never sat in the dog pound.
My son-in-law is a big Browns fan, and he tells me about what happens when he sits in the dog pound. He ends up covered with beer and or puke. Yeah.
I hear the dog pound's pretty brutal.
Yeah.
That's fun to me.
Yeah. The average Cleveland fan, and I'm not saying you guys are average by any means, but the average Cleveland fan is somebody who, if they ever had an intelligent thought, it would die of loneliness.
Sounds about
You know
right.
what? Cleveland is a nice, dirty place, and I love it.
Is that Kylie?
Yeah.
Why would you like... You're not from Cleveland.
My boyfriend is from Cleveland.
Oh, well, tell him I don't like him.
All the time.
Tell him I don't
think
like him.
that's where I'm going to move when I graduate. I heard there's lots of really good opportunities out there for engineering jobs.
What's wrong with people from Cleveland?
You don't like
Other
dirty
than
rock?
the fact that they're dirty, moronic idiots. I'm sorry.
You know what? My baby is half Cleveland, so we better stop there.
My daughter, my oldest daughter, is pro Cleveland, and anyway. Okay, here, guys. All kidding aside, let's make let's do this, guys. Yeah. So let's preset, okay, guys? And let's make clear do one of these numbers. When I went to Toledo, I met a lot of people from Cleveland, and especially Browns fans. At least back then, I think it's still true. Browns fans never lost. They never. Every time the Browns lost, it was the referee's fault. Pretty much every single game, and that was the truth. Everybody blames the refs.
Not actually in any sports. I just know that my boyfriend's mom, every time there's a game, she always says, "Go Browns."
Go Browns. My wife's a big Browns fan. Like really, really huge Browns fan.
So it's a split household.
Oh yeah. Well, I really don't care for NFL.
Oh yeah. Oh, that's right. There's like I don't even know. Cleveland Indians is the baseball one. Yeah.
Yes.
My mom loves
Indians don't exist anymore now. It's the Guardians. Okay, guys. I don't know what Q is going to do. I really don't. But let's run through the timing diagram and figure it out. Sound good?
Yeah.
Sure thing.
Okay. So, we know, right? If it's a rising edge triggered, we know that if anything's going to happen with regards to the clock, it's going to happen on the rising edge, right? Right, guys? Help me out. Come on.
Yeah. All right. So.
Oh, I know what I wanted to do. Here, let me change preset and clear over here. I'm sorry. What was that? Hot pink? Hot pink and green, I think. Here we go. Okay. I think it'll be interesting. Ready to roll?
All right.
Do we know what Q... Oh, I have to bring Q down. Sorry. That was purple. Too many colors. Okay. Do we know what Q is going to do in the very beginning? Do we know what Q is before the first active edge?
No, we don't.
No, we don't know. So
I disagree with you. Why?
Oh, I suppose
preset
clear
is
is
active.
high.
Shout it out. Was that you, John? Somebody said something about preset.
Preset is active low, so preset is active.
At the very beginning, is it not? Is this John or Elijah? I can't tell you guys apart.
This is Dalton.
Oh, God. I'm sorry. I'm really sorry, Dalton.
All good.
I can't wait till we're on, at least I can see you guys. Guys, presets active. Do you see that, everyone?
Yep.
Right here? So, presets active, so that means the flip-flop is going to be high. Q is going to be high. Okay?
So whenever preset is active, Q is automatically high?
Yes.
Depending, like, it doesn't matter if preset is high or low. Q is just always high if preset is there.
Run that by me again?
So it doesn't matter if preset is high or low. Q is always high if preset is there.
If preset is low, Q will be high.
Oh, so if preset is high, then Q will be low?
No. It was preset. That's where we get the name, preset. It didn't wait around for the clock. It immediately had the flip-flop, made the flip-flop go high. And when preset is removed, which it is right here, right? The flip-flop behaves normally. Okay? And that's when the active edge of the clock matters. Okay?
Mm-hmm.
Did I answer your question?
Yep.
So,
Like here, right? Yeah, we're going to get there. But yes, you are correct. If this were clear instead of preset, and this were preset instead of clear, the flip-flop would start off in the low state. Yes. Yes, it's a violation, just like with the SR latch. It's a violation at preset and clear active at the same time. And it's quite obvious when you read the data sheet that they tell you flat out, if you send preset and clear low at the same time, weird stuff is going to happen. Okay? So, when can, now that preset and clear are both inactive, do you see that we have to wait for the next edge of the clock for anything to happen?
Right.
And what's D going, or Q going to do on the next clock edge?
Well, at this point, D is low, so Q is going to go low.
Okay? In here, nothing changes with preset and clear. So we're going to have to wait around for the next active edge of the clock. What happens?
Well, D is still high, clear is still disabled, pre is still disabled, so it's going to stay high. Well, stay low, I should say.
Well, but D is high.
My bad. It should go high.
Yep, very good. Good job. And this transition of D going low, that doesn't matter because it didn't happen on the edge of the clock, and that's a horrible drawing of clock.
It's past the clock pulse, and I can gather that from the dotted lines.
Yeah, I try. It'll be a whole lot. It'll be a whole lot more clear on the opportunity, so you don't have
clear
to
run on the same logic as pre? That is, immediately set it to 0 regardless.
They are asynchronous, right? Asynchronous, preset, and clear. They don't wait around for the clock to happen. They immediately affect Q. Okay? So, preset and clear are still inactive, right? But, oh, wait a minute. Clear goes low right here, doesn't it? What happens? Who said that? Good job. Well, the technical term is they override D, and the clock for that matter. They override D and the clock.
Is it because preset and clear are enablers?
It's the way the chip is designed, and yeah, they're I don't know if I'd call them enables. They are asynchronous inputs. Okay.
Could you real quick just do a quick summary of why, so far up to this point, why Q is doing what it's doing? I'm a little confused.
Okay. We start off preset, right? Do you see that?
Mm-hmm.
Do you see that? Is that?
Yeah. So just because preset is there, Q is high.
Preset's active, so Q goes high.
Okay.
Now, when we take preset away, it stays high. Okay. But with preset and clear inactive during this time, what Q is going to do is it's going to follow D, because preset and clear are both inactive.
Why are they inactive?
Because they're high.
Oh, so if they're both high, then they're inactive?
Well, if either one's high, that particular input is inactive. Yeah. Yep.
Okay. Okay.
Here, does this help if I draw the zero, the zero level, so you can kind of see where it's high and where it's low?
I was confused because I just realized with the bar over pre and clear, that means that they're active when they're low.
Mm-hmm. Yes, ma'am.
Pre and clear are active simultaneously. Which takes precedence?
Yeah, look at the data sheet. The data sheet tells you that you're an idiot because you sent preset and clear active at the same time, and you're not supposed to do that. The
So
data
this
sheet
would be a good application for a decoder then, right?
Yes. No, Brian, the answer to your question is the data sheet tells you that operation is not guaranteed if they are both low. Because if you think about it, what you're doing, if you send both of these active, in other words, they're both low, you're telling the output Q to go high and to go low at the same time. What's it supposed to do?
Nothing good.
Right. It's kind of like a kid locked in a custody battle, right? Do I go with preset or do I go with clear? Okay. Did I answer your question, Brian?
Yes.
Okay. Let's see. What were we doing? We were kind of recapping to get up to here. Mm-hmm. So now they're both inactive, right?
Yep.
This was Kylie that was asking, correct?
Mm-hmm.
So they're both inactive, so they don't affect Q at all. And then we get an active edge of the clock. What's the state of D when this active edge occurs?
Low.
It's low. So Q goes low because Q equals D on the active edge of the clock.
Okay.
Okay.
Mm-hmm.
There's still preset and clear is still inactive, and we get another edge. This time D is high, correct?
Yep. And Q goes high.
Q goes high. Yep, you got it. Mm-hmm. And then all of a sudden, out of nowhere, clear went low. So what happens to Q?
It goes low.
It goes low. It goes to the asynchronous clear state. It does not wait for this. Oh, change this to, not that it matters, guys, but I wanted to show you this. change D to that so it goes high before the active edge of the clock, guys. Okay. So if that happens, clear overrides what D is trying to do when the edge occurs. That was a question that was asked a couple minutes ago. Okay. Preset and clear override what D is doing if either one is active. Does that make sense, everyone?
Mm-hmm.
Right.
Everybody good?
Any asynchronous system attached to the flip-flop will trigger immediately. It doesn't have to wait for a rising edge.
Preset and clear, definitely, yeah. Uh-huh. Yep. So, do you see, again in summary, that when the active edge of the clock occurs, the fact that D is high, that's immaterial. The flip-flop ignores it because it's being told to clear. So Q goes low, and it stays low until either preset or clear tells it to do something, or we get an active edge if both of those are inactive. The next active edge of the clock is right here. But before that happens, look what preset does. So what's Q going to do when preset goes low, guys?
Gonna go high.
It's going to go high. And do you see that the fact that D is low during this time, that's ignored because preset overrides D. Okay, guys?
I got one quick unrelated question before I forget. Lab 6 is due at midnight tonight.
Yep.
All I have left to do on that is to just shore up those cost calculations. I've been holding off on them to ask you before. Would it be acceptable to lag half an hour or so behind midnight?
Oh,
I don't
care. I don't care.
Right, I just really don't want to miss this for...
Nope, you're fine.
Appreciate it.
You're fine. Okay, guys. Now we have... So now preset went inactive, but clear went active. What happens here, guys?
Q goes low.
Keep on going, Kylie.
And then even it stay low until then it gets to pre, and then it goes high.
It's preset, so yeah.
Okay.
Okay. Then what?
And it stays
They're both
low.
inactive.
Yep. And then it so it stays low, yeah, until it hits that next pre, or wait, that's clear, yeah. And it goes low again when clear goes down.
And once again, D is totally ignored.
Mm-hmm.
And it stays that way until we get hit again. Okay? Guys, that's how you do it. Good job. Real good job, guys. I'm proud of you. Really proud. Make sure you do this tomorrow, okay?
Well, I'm happy to see that what I've got on my paper matches up with what we worked out there.
Yeah. Awesome job, guys. So that's preset and clear with a D, and that's a timing diagram with a D. Do you want to move to JKs?
Yeah. And T's come after JKs because a T is just a JK with both of its...
T is a special case of JK, yeah. Does anybody want to grab the I would think this might be kind of nice to have in the chat if you want to refer to it. I would think.
It's uploading.
Okay, so I can clobber this. We can go for another half hour or so. Okay.
Alrighty.
Okay. What can I get rid of? Everything?
Yeah.
Yeah. If we're only gonna go for a half hour, I would really like to look at sequencers. That's kind of the one
Okay.
I'm.
We did a time. Didn't we on the board? Didn't we do a timing diagram with JK?
What do you mean? Like in class?
Didn't we do something like that? Yeah, in class.
Let me check
Didn't
my
we do
notes.
something? I'm pretty sure we did.
If it was done, then it hasn't been pinned yet, but it would
I
be nice
write
to fish out
everything that
from one
you
of the
write.
lectures.
Well, let's put it this way. Could you do a timing diagram with a JK
I think
or a
so.
T?
Yeah, I think
No.
so because.
Okay.
Well, we should maybe we should just try to quickly go over. Because
Okay.
D, we know that pre and clear has precedence over D, but then how does that apply to
They also
J and
take
K?
precedence over J and K.
Okay, and then what about if they're both invalid, or what would happen with J and K? Does J have precedence over K, or either or?
Let's take a look at it real quick to clear your confusion up, okay? All right?
Mm-hmm.
I'm going to get rid of this top in blue, okay, guys? All right?
Yep.
Talk to me. Come on.
Yes.
I have the
Alrighty.
whole thing on the board. If you can erase it all if you want. The whole thing is
Well, I don't want to erase the timing diagram because we can reuse it for JK.
okay.
Also, Professor, this is Josh and Sam. Will you have time after you're done with this to briefly go over opportunity plans with Sam and I?
Yes, I was planning on asking you if we could quickly go over things. I have the versions. I have a version. I just have to create the other versions.
Okay, sounds good. Stan.
I'm sorry?
Good to hear. Yeah, Stan. Good.
Okay. All right. As soon as we're done here, at most another hour. Okay, so like 11ish. Okay.
Sounds good.
Okay. Thank you. Each and every single one of you guys you need to send a Christmas card to those two guys. Oh my gosh, they have been so good. They've really been a huge help. Oh shoot. Oh. They really have. They've been a lifesaver. We ready to roll, guys?
Alrighty.
Yep.
Right?
Yep.
Jack Kilby.
Kylie was the only one that said anything. I am very disappointed. I don't think anyone's ever confirmed that. To be honest with you, I don't think anyone really truly knows what the origin of the nomenclature for the JK is. It's a good story to name it after Jack Kilby, though. I guess he was a really good guy and a phenomenal engineer. Anyway, It's got 4 states. Oh, here, truth table time, right? This is no change, correct?
Yep.
Yeah, that's right.
This is reset.
Yeah.
This is set. This is toggle. Okay. I'm going to clobber D out of our timing diagram, and I'm going to put J and K above it, above clock, because we simply ran out of room. Okay, let's see. Do we need to go through anything like we did with the D, or can we dive into the timing diagram?
No, we're good. I think.
Just go right ahead. 0 here. Is that a 0 or is that an O under those Qs?
Old. This is Q old.
And in every case, yeah, Q equals for JK00, Q old, Q not equals Q not old.
Okay. Did I answer your question?
Yep.
Okay. So I'm going to clobber the truth table and let's do some meaningful JK stuff. Sound good?
Oh, I didn't have it.
Oh, crud. I'm sorry.
It's okay. Would you? I had it almost written down, but would you be able to just tell me? So, 00 was Q old, Q not old, and then that was reset, right?
Here. Right? Reset. Set. This is no change. Right? No change. You buy that?
I can't barely see it. Okay.
Can you see that?
Yep.
Okay. And this subscript here is a O for old or original.
Yep. I heard that part.
Okay, cool. So we'll have J, start off low. Oh, not there. And then, yeah. Okay. So let's see what Q's going to do now. Okay, guys? Ready?
If you would just let us grab that for a second.
Of course.
Can't see the whole thing.
Oh, man. I have got to get a new eraser. Ugh. You see these smear things on the board? That's from the blasted eraser. It only took me a couple semesters to figure that out.
So we kept everything the same except obviously we have a J and K now, and our Q is different.
Mm-hmm.
Okay.
You guys ready to roll?
Alrighty.
Okay. Do we know what Q starts out as?
Well, it's the same story as before.
It most certainly is.
Yeah. Pre is active, clear is not.
Good job. It most certainly is. Okay. So preset is low, which means it's active. So Q starts off in the 1 state, right?
Mm-hmm.
And that is preset. Okay. And then preset gets taken away, but Q stays in that state until something tells it to do otherwise. Okay.
Yep.
So stays here. Now they're both inactive. Preset and clear are both inactive. What are J and K? Up here. J is high, K is low, right?
Which means it should be set. That is, Q stays high.
Well, K is high, so shouldn't it be reset?
My mistake. I was looking at J high, K low.
Yeah. Do you guys see that? Talk to me.
I do.
So Q is going to go reset. Okay. And then they're still inactive during this time, so we look at the next clock. What's going to happen?
Both of them are active, so it should be toggle, which is to say flip whatever Q is at that moment.
Do you see that, guys? It goes high because J and K are both high. That's the toggle state. So whatever Q was, it changes value. It flips to the opposite value. Okay. Oh boy. Now we have clear going low. What happens?
Well, immediately Q is going to shoot to low.
Does everybody see that? Does anybody not see that, I should say?
And it's going to stay low until pre goes low, at which point it'll shoot back up to 1. Which is the same behavior from the D flop.
Exactly. Yes. That's what I wanted you guys to see. And yeah. Stays low.
So for, a long spate here, its behavior is just controlled by pre and clear. There's no real chance for J and K to come into action.
Yeah. Yep.
But the principle
Some guys
was already the principle was already established. You still compare it at rising edges. Just take a look at the table for JK to see how it should behave.
Uh-huh. Are there any questions on that?
So Where? Okay, where on the diagram? I might have missed because I was still trying to write the lines.
Yeah.
Is there anywhere where the behavior was dependent on J and K? I thought in the beginning.
Absolutely. Yes. So here we're in the preset state, right?
Mm-hmm.
Right? Then we get a clock edge that is still overridden by preset. Okay?
Yeah.
Then they're both inactive, so now we look at J and K.
Okay.
J is low, K is high. This is reset.
Oh, I see.
Okay?
That makes sense because you're looking at your table.
Yep. Over here.
Okay. Yeah.
And then here they're both still inactive, and J is high, K is high. So we're in the bottom row of the truth table. This is toggle. Okay?
Okay.
And after that, preset and clear take over. I wanted to show you this because some guys actually use like a JK or a D. They just use preset and clear. They don't care about clock. They don't care about J or K or D or whatever. They just use preset and clear because they want to latch in an event happened and then clear it with some other like a reset button or something like that. Reset signal. Okay, so some guys just use a flip-flop for that reason. Okay.
Mm-hmm.
All right. Ready for sequencers? Talk to me.
Thing.
Here we go. What do you guys want to take tell you what, take a cartoon. I got to go get a refill on my water. So somebody upload that because that might be of use to somebody.
Give me a chance to get rid of my plates too.
All right. I'm back. I have a second eraser in here somewhere. Okay. What can I get rid of?
I put the screenshot. Let me double check if it uploaded.
Okay.
Yeah, it's all good.
Okay. Jeez. When you have to use the eraser long ways, it really takes a long time. Okay. Let's do a real simple sequencer. Tell you what. What if we do a sequencer where we really don't know how we're going to implement it? Okay. Yeah, that'll work.
Can you make me a corn dog? Thank you.
I can make you one, but it will. It's kind of a long way for delivery.
Forgot. I didn't realize.
Okay. That's enough. Okay, here we go. Okay, I have defined everything except what? We got to define that. Where does, if we're in this sequence over here, and x goes from 1 to 0, where do you want the sequencer to rejoin the main sequence of 89 and 763? Do you want the arrow to go from here, from 365 to here, or from 365 to 89? Your call.
The second of the two.
Up to 89?
Yes.
Thank you. Trust me, guys, the rest of your life doesn't depend on this. Okay. Ready to go?
Sure thing.
Yep.
Okay. That's the statement of the problem. Kind of open-ended, isn't it?
Precisely. These sorts of things, always the hardest thing is beginning them, honestly.
Yeah, so many choices, right, guys?
Mm-hmm.
So, how many states do we have, guys? How many states do shout it out?
Looks like 3.
3, right? So how many flip-flops do we need?
2.
Yeah, we need 2.
We have 3 states, so log to the 3 flip-flops, if I remember.
So we need the ceiling which goes to what, guys? Doesn't this go to log base 2 of 3 is 1 point something, right? It's more than 1. So it's 1 point something. You go to the ceiling, so we need 2 flip-flops. Okay? We are allowed 1 JK, and we can use either a D, T, or JK for the other one.
Yep.
Oh, no. Okay, yeah. Yeah, let's do it. And we don't know which one, like if we think that we can implement it, you know what, here. And either a T or D for the other flip-flop. We can't use 2 JKs, in other words. Okay? So, we're going to have a JK, or we can use a JK, but we can use 1 and only 1 JK if we choose to do that. The other one's got to be a T or a D. Okay? We could choose to implement it out of 2 T's, or we could choose to implement it out of 2 D's. Okay? All right, and if we don't know, we could pick a D and a T for that matter, right?
Mm-hmm.
It's not stated which flip-flop is which. which is fine. That's all part of the solution. Okay. Now, do we really need to run with these states as given?
We can rename them to be 0, 1, and 2.
Yes, we can. So, renumbering states. Okay. So, state 89. What do you want to call that state?
Let's call her 1, because that's kind of where from all of the sprouts. Well, 0 in that case.
Want to call it 0?
Yes.
Okay. So we're going to use 0, 0 for that state number. How about 365?
I kind of want to call that 2, not 1. If only because 763 has a little bit of a simpler relationship with 89.
Okay. Okay. Oh, timeout. I didn't ask you. 763, do you want to call that state 3 or state 1?
I want to call that... That's the one I wanted to call state 2.
763?
Yes.
Okay, so if we call this 2, what's 365?
Oh, then that's got to be state 1.
Okay. Your choices would be 1 or 3, right?
Yeah.
Okay.
I mean,
now
3 isn't really a choice, is it? Considering that we start
you
with
can
0.
you can use 3. If we use 3, then that means that 1 would be the missing state, right? We're going to have a missing state no matter what, right?
Right.
Okay, you ready to roll on this, guys?
As ready as I ever will be.
Everyone else, you guys ready to roll? Talk to me, come on.
Yeah.
This is state 0, 0. This is state 0, 1. And this is state 1, 0, base 2. Okay? So, I'm going to go get some paper towels to erase because this is ridiculous. Yeah, that you can assign. Okay? So, do you see, ladies and gentlemen, that we have to, the current state to next state portion is fairly straightforward, and we're going to do that. But the excitation, because we don't know what the best choices for flip-flop 1 and flip-flop 0 are. We don't know. So we have to find the excitations for, flip-flop 1 being a JK, or flip-flop 1 being a T, or flip-flop 1 being a D. And the same thing with flip-flop 0. Okay? And then we got to pick the best implementation. Does everybody understand that? You guys are not giving me a warm fuzzy.
My bad. My dad just had to say something in the background.
Quite all right. You've got 40-something partners in crime, I think.
Yep.
Yeah. Mm-hmm. Yep. Ready to do it?
Let's get to it.
you have, it's easy. It's nowhere near as bad as you think. In fact, it's a lot easier than trying to get this crud off my whiteboard. Okay. Oh, yuck. I forgot about that. Okay, so we have the current state. Guys, yes, no? But the next state has an x equals 0 column and an x equals 1 column. Yes, no?
Yep.
Yep.
Okay. So if we're in state 0, 0, and x equals 2, I'm sorry, x equals 2, and x equals 0, where do we go?
To state 1.
With x equals 0?
Or
Don't we go to state 2?
Or yeah, sorry. That's what.
Yeah, right?
Yeah, that's what I meant. I
Tell
don't
you
know why
what.
I said 1.
That's all right. That's all right. That's all right. That's all right. How about if I redraw this with our renumbered states so it'll be a little bit cleaner? Sound good?
Okay.
Okay, this was state 0, 0, base 2, yes, no? This is state 1, 0, base 2, and this is state 0, 1, base 2. Okay? So now, if x equals 0, and we're in state 0, we're going to go to state 1, 0, right? If our current states can be 0, 1, and 2, so if we're in state 1 and x equals 0, what happens? We go to state 0, don't we?
Mm-hmm.
If we're in state 2 and x equals 0, where do we go? 0, 0, right? Now let's take a look at the x equal 1 input. If we're in state 0 and x equals 1, what happens? Exactly. If we're in state 1 and x equals 1, what happens? We stay in state 1, right? Yep. And then if x equals 1 and we're in state 1, 0, what happens?
We go to 365, aka 0, 1.
0, 1. Okay? These are the transitions, guys. Okay? So, for x equals 1, there's several ways to organize the excitation table. I'm just going to do it one way, okay? J1, K1. Yeah.
Where are we getting the next state from? So we're looking at 0, 0. And if we go by x equals 0, that takes us, I don't get it.
If we're in state 0, 0, and x equals 0, we travel along this.
Okay. So we're literally just looking at the x. We're just following the arrows based on.
We are following the arrows. Yes.
Okay.
The arrows, let the arrows be your guide. Okay? To answer your question? Okay, so for x equals 1, if flip-flop 1 is a JK, we're going to have J1, K1. Okay? If flip-flop 0 is a JK, we're going to have J0, K0. We don't know what the flip-flop types are going to be. Okay?
Right, so we're going to have a J1, K1, and a J0, K0, and x equals 0 and x equals 1 case for both of them, right?
Yes. But we could also have the flip-flop 1 could also be a D, couldn't it?
It could. So instead of having a J0, K0, we could have a D?
Yes. Or we could have a D for the least significant flip-flop, right?
Yeah.
Or
don't perfectly follow. I understand that you're supposed to have one JK, which is going to be J1K1 there.
Or it could be J0K0. We don't know.
Right. So right now what we're doing is just establishing the excitations for any of the potential ones.
Yes, and then we're going to look at the best combination, which means lowest cost, does it not?
Right.
Can I get rid of the transition diagram?
Yes.
Because it's captured right here, is it not? It's captured right here on the table, right?
It is.
So, and guys, remember, it looks a lot worse than it really is, because the excitation tables can be pretty easy to figure out. Okay, this is with x equal 0, and with x equal 1, we have the same scenario. Okay, J1, K1, J0, K0, D1, D0, T1, T0. Okay. So let's start filling this bad boy out, okay?
Why do we have J1K1 and J0K? Actually, never mind. Since J and K are their own things, you need 2 columns for them.
Yes. Yep. Guys, the reason we need this, what if we have flip-flop 1 equals a JK and flip-flop 0 equals a T? So we would use, we would need this excitation, right? Right, guys?
Right.
For, yes, no? We need this, and we need this, because x can be 0, x can be 1, okay? If flip-flop 0 is a T, then we would need this column and this column over here, okay? But what if we flipped it? What if it turns out that the best implementation is a D for flip-flop 1 and maybe a JK for flip-flop 0? In that case, since the most significant flip-flop is D, we would need this column and this column for D. And we would use the J0, K0 because it's the least significant flip-flop right here and right here. Okay? That's why we need all the columns. Yes. Yes. Yep. Yep. Okay? As we do this, it'll make total sense. Okay?
All right.
Let's take a look at the x equals 0 part first. If we're in state 0 and x equals 0, we go to 1, 0, do we not? Right?
All right. Could you repeat that sentence?
If we're in state 0 and x equals 0, we go to state 1, 0.
Yes.
Right? That means that the most significant flip-flop, this is Q1, Q0, and these next states are Q1, Q0, guys. So this is the most significant bit. The most significant flip-flop goes from 0 to 1, right? Do you remember that, guys? Q old to Q next, right?
Yep, I've got that in my notes.
You should. Am I speaking Greek or what, guys?
The sequencer makes sense. It just takes a lot of thinking to iterate through it cross-referencing different tables.
I'll buy it. Okay. This is the excitation table of the JK, guys. Right?
Yeah.
Mm-hmm.
So to go from 0 to 1, what do we need? 0 to 1. Don't care 1, yes, no?
Right.
Okay. What does the least significant flip-flop do?
Stays the same.
And what do we need for that?
Oh, 0. Don't care.
You got it. Okay. Do you want to go down the table? Staying with x equals 0? Do you want to go to x equal 1?
Let's fill out J1, K1, and J0, K0 before moving on to...
Okay, that's
just
fine.
going down.
So are we staying with x equals 0?
Yep.
Okay. So x equals 0. So if we're in state 0, 1, and x equals 0, we go to state 0, 0, do we not?
Yeah,
that's what the
0
table is
goes
showing.
to 0, so that would be 0x, right?
Yes, it would be.
And then
let me
1
change
goes
colors.
to 0, so that would be x1 for J0, K0.
Does the orange show up?
Yeah.
Okay. So what do I put here, guys?
1 goes to 0, so that's going to be x1 for J1, K1.
Does that make sense, guys?
Yes.
Makes sense to me. This format you have where you split x equals 0 and x equals 1 into two distinct categories is a little bit better, I think, than what's on the lab, where you have x equals 0 and x
You can
equals
do
1
it either
for
way.
each one.
You can do it
Yeah.
either way.
I'm saying this is a little easier to intuitively get. Anyways, for J0, K0, 0 goes to 0, that's going to be 0x.
Okay. Does everyone understand where their values in orange came from?
Yep.
Okay, let's go to D's.
The de-excitation table, man, this is one of those cases where something really simple.
Done. Yes, no, guys? Talk to me.
And that's because it's always the same as x equals 0.
It's always the same as the next state.
Okay.
All right.
In fact, we can do it for x equals 1 right now if you want, for the D's.
Yeah, that's just 0, 1, 0, 1, 0, 1.
Do you see that, guys?
Okay. Yep.
It's literally that simple. Just copying. Always. Yeah, yeah. See, it seems like, oh my God, we're going to be here all night doing this. Well, not really. What about T's?
Really quick.
Go.
I don't know if I messed up. 0, J1, K1, shouldn't that be 0 to 1, 1 don't care?
Which one? Which entry?
Top of J.
Here?
Right there, yep. Shouldn't that be 1 don't care? Because.
Oh my gosh, good catch. I'm an idiot. That's not breaking news. I already know that.
I didn't know if I was wrong.
You're perfectly right. Okay, T1, T0. What do we got?
The T-excitation table.
It's almost as simple as the D's, guys.
Right.
Isn't it? Okay, so.
If it stays the same, it's going to be 0. if it
changes,
it's going to be 1.
You guys got it. Both of you. Nailed it. Okay? So for x equals 0, we're in this next state column. Okay? Do you see that for state 0, 0, the most significant flip-flop toggles, the least significant stays put?
Right.
Do you see that?
So it's going to be 0, 0?
No, it's going to be 1, 0. The most significant toggles.
Right.
Do you see that, guys? Talk to me.
All right.
Yep. Makes sense.
Keep on going. 0, 1 to 0, 1. I'm sorry, 0, 1 to 0, 0. What happens? Yep. 1, 0 to 0, 0. What happens?
1, 0.
Yep. You got it.
Okay, so
we're almost done. Go on.
So why? Why is the T?
T. If when we go from current state to next state, okay?
Mm-hmm.
If the Q tog, if it changes, it doesn't matter whether it's going 0 to 1 or 1 to 0. It doesn't matter. If it changes, the T bit has to be a 1 to make that change.
Okay. And
if
the
it
second one
doesn't,
change, so it's a 0.
it stays put, right?
Okay.
Does that make sense, Kylie?
Yep, that makes sense.
Okay. Are we ready for x equal 1 stuff?
Sure thing. Which is the same story as x equals 0. We're just looking at the other side.
Yep, other one.
We're looking at this column now, guys, for the next state information. I'll do the stuff up here. You do it on your paper, and you can tell me what I screwed up, okay? All right?
Mm-hmm.
Sure thing.
Let me change colors for you. Zero to 0. 0, don't care. And then 0 to 1, don't care. 0 to 1, 0 to 1. So that's a 0, don't care. And a don't care, 0.
I got my table filled. I'll wait until you're done to check.
Yeah, it's somewhat straightforward. Okay. Now I can use this color. Okay. Is that what you guys, did I get what you guys get?
I don't understand the T for x equals 1.
Did I screw that up?
Difference between
current
on the left and the columns in x equals 1. The first digit is always going to be T1. The second is going to be T0. If it changes from currents to x equals 1, it's going to be a 1. If it stays the same, it's going to be a 0. Taking the first row as an example, 0 is the first digit in current, 0 is the first digit in x equals 1. That's not a change, so T1 is going to be 0. Now, the second digits in both of them are 0 and 1 respectively, which is a change, so T0 is going to be 1. Does that check out?
Okay, yeah.
Does that make sense, guys?
Yeah, thank you.
Who said Professor?
I said, okay, Professor Junior.
Hey, do I get extra credit for that?
Your reward's in heaven, Brian. So, guys, does everyone have this same information in your notes right now? Because now we're going to have 8 K maps to do. The good thing is they're really, really, really easy. You ready to roll?
Already.
Yep.
Okay. J1, it's, remember I told you it's best to do J's and K's together? You know, so do J1 and K1 at the same time. And we have 2 inputs, 2 states, plus we have the X input, okay? And I believe most of you like the Carnot maps that go off to the side, as opposed to up and down.
And I tell you what, this is going to make Lab 8 a lot easier.
Yeah, definitely.
Yeah, it's just another example of what we've done. Yep. Practice makes perfect, huh? That's why I haven't assigned a lot of homework. Because I figured that between lab and lecture, we're doing...
Yeah, we won't have any more for this semester, will we?
Nope.
Homework?
No,
Okay,
no, you guys are done. We have an unused state, do we not, guys?
We do. That's 1,
State 3. State 3, right? So if this is Q1, Q0, and that's X, Q1, Q0, and this is X, do you see that these are going to be don't cares, guys?
Why? Wait.
Right? So now we just go through, right? So
You
in
said
the
why are they
X,
don't care?
because it's a missing
because
state.
no. Okay, yeah, I see.
So if X equals 0 and we're in state 0, 0, we have a 1 don't care. So it's a 1 don't care. Right? If we're in state 0, 1, it's a 0 don't care. And if we're in state 1, 0, which is way over here, it's the don't care 1. Then you go over here, guys, to this column, and you do the same thing. 0 don't care for state 0. State 1, 0 don't care. State 2, which is way over here in the bottom right hand corner, we have a don't care 1. Okay? Talk to me.
This is something that I get. It's just a little bit slow on the filling process. I understand what I'm doing, but I gotta keep checking the table.
I understand.
Okay, so X is 0. Can you run that one more time?
Run what?
What you just did with those 2 K maps. I know it. It's in my head. I just...
Okay. So, if X equals 0, right?
Mm-hmm.
If we're in state 0, 0, that means we are here.
Yeah.
In each map, we're here.
Uh-huh.
J1's 1.
Okay,
K1 is a don't care. Okay?
Okay.
Then if we go to state 1, again, X equals 0, it's a 0 don't care.
Yep. Okay, I got you.
Does that make sense?
Yep. Yep, that makes sense completely.
Okay. It should come as no surprise to you that K1 is going to be a 1. Do you see that?
Yeah.
Mm-hmm. You can do that. A lot of guys do it that way. There's all sorts of tricks you can do that are valid, okay? To help speed up the process. You just got to make sure they're valid, right? What's J1, guys?
I want to say I can just make a tie there. Yeah, like that. And we don't need to go for that group of 4 on the right.
Absolutely not, because they're don't cares. So J1's going to be an X knot, ended with Q knot, Q0 knot. Yes, no?
Yep, that makes sense.
Okay. And we're going to keep on going. And we're going to have to wrap this up. We're going to keep on going. J0, K0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, da, 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 da. So we're going to have a 0. Oh, don't forget you don't cares for state 3, guys. 0, don't care. Don't care. 1, 0, don't care. And then you go here. 1, don't care. Don't care. 0, 1, don't care. Okay, guys? I get J0 is equal to simply X. If I did it right.
Looks to be.
And then this is going to be just as easy. K0 equals X naught. So right off the bat, it's looking like flip-flop 0 should be a JK. Assuming that one of the D's or T's works out. Okay. Ready for D1?
Yep.
Does everyone have this information for the J's and K's?
Yes.
Yeah.
Does anyone not have it? Okay, I'm going to move on then. You got it. Yep. It might be that the D's and T's, even with the really simplistic flip-flop 0 using JK for it, might be D's and T's yield something simpler. I don't know. We got to do the math. We got to do the work to figure it out. By the way, this is engineering, in case you're wondering. This is not just an academic exercise. This is real engineering. If that don't make your blood boil, nothing will. Or no, that's not. No, if that doesn't make your blood, that doesn't get your blood pumping, nothing will. How about if we say that?
Okay.
You're going to use software, buddy. Yeah, you're going to use software. Okay, D1, D0, but it's important that you know how it works. So we got a 1 here, and we got a 0 here. And if we're in state 1, X equals 0, so we're in top row. We got 0 zeros all the way out, don't we? For X equals 0.
This is for the first one is, oh, I see. Never mind.
And then we move to X equals 1. So we got 0, 0, 1s all the way out.
Mm-hmm.
Oh, yuck. What's D1, guys?
That is going to be pretty much isolated, just...
We can do
X,
absolutely
Q1,
nothing
Q0.
with it. Yeah, and they're all inverted. What's D0? D0 is a lot nicer to us.
D0, on the bottom, it's going to be 1. So I'm thinking it's 1 plus that vertical row, which is 0, 1, 1, 1, 1, 1, which should be 1 plus Q1, Q0.
Why do we...
Why do we need... I'm stupid. I don't even need to turn that into a 1.
We don't need that, do we?
Yeah, it's just a 1.
Can't read. Is that on the top row 0010?
That's 00x0.
Oh, okay.
Is that better?
Yes.
Yeah.
Okay, then we got T1. And Murphy's Law kind of bit us on D0. Which is the flip-flop? Which flip-flop, 1 or 2, or 0 or 1? Do we need one of the T's or D's to be really nice to us? We already have a JK. If we can use a JK for flip-flop 0, that's not too bad.
Right, then we want 1 to be very nice to us.
Yes, and it's not. Right?
Yep.
Murphy's Law, ladies and gentlemen. I should call it the engineering law. Don't forget your don't cares for the state 3, guys. So we have a 1 and a 0. A 0 and a 1. It's not looking too good, guys. 1 and a 0. It might not be horrible. Then we go this way, and we get a 0 and a 1. Yeah, it's going to be bad. Well, it depends on what that is. Then we have a 0 and a 0. And then we have a 1 and a 1. What's T1, guys?
Well, we have a group of 4 on the right. That should just be 1, right?
Yes, no? Isn't that Q1?
Or Q1, I should say, yeah.
But we got to include this bad boy too.
Yep, and we can just make a group folding across 000 and 010, so that's X naught, Q0 naught.
I'll buy it.
I figure now is a good time as any to start learning how to do these by eye instead of writing them out every time.
The more you do it, the more you can, right?
Right. And on T0's case, we can make a group along the bottom between 100 and 110. Which
do you see that we can do this, guys? Do you see that we can wrap around here?
Yeah.
I mean, it's real tempting to group this one with the don't care, but that doesn't help us at all here.
Mm-hmm.
If we do the wraparound, we grab both ones, right? What do we do about this guy?
We can do this? Use the top don't care there to make a group of 2 that's 001 and 011. So we cut out the one in the middle, which should be X naught and Q0. I think.
Pretty sure that's right.
Right, well...
Okay. So, guys, did everybody get what I have here?
I've got it down.
Does everybody else?
Yeah.
And do you agree and do you understand? Those are the main questions.
I now comprehend that what we're doing here was evaluating the excitations for each and every one of the available flops for both x equals 0 and x equals 1. We created the Boolean logic for those with these 8 K-maps here. We've established that, in my opinion, we should use J0, K0, and J1, K1.
Okay, what can I get rid of, ladies and gentlemen? Can I get rid of this stuff down here? Or transition table? Is that okay?
You can get rid of everything.
Okay, because we gotta wrap this up. I gotta get with Sam and Josh. So guys, let's take a look at cost. Okay, cost. If we have a JK for flip flop 1, what do we have? What's the cost? Well, it's 2 plus, because there's 2 inputs, plus number of literals. How many literals? This guy doesn't count.
Just 2?
Yeah,
2.
Just those 2.
Plus 1. There's 1 gate, an AND gate. That's 5, right?
Mm-hmm.
What's J0, K0? 2 inputs plus...
Yep. No gates at all, and
none.
Just 2 literals.
Okay. So 4. Do you see that, guys? Everybody?
Yep. The input is J and K.
I'm sorry?
Like you say, there are two inputs. I just want to know
2
what
inputs,
are
J and K. J and K.
Okay, gotcha. Thanks.
Yep. So, what's D0? No, what's D1, guys? What's the cost of D1? That's down here. We got 1 input, just D, plus how many literals? 3. Plus, if we assume we got 3 input gates, yeah, if we assume we got 3 input gate, yeah. So that's the cost of 5. What's D0? What's the cost of D0?
3?
I get 1 plus 1.
Yeah, 1 plus 1.
Oh, there's no gates. Yeah.
Okay. So using a D flip-flop for flip-flop 0 is looking real good.
Why are we counting 1 as a literal?
Because there's 1x.
What, here?
For D0?
Yeah.
Oh, my mistake. I have it written down as 1 here, not X.
What's T0? That's up here on the board, guys.
3 plus 2 plus 1, right?
Well, we got 1 input, T, plus, you said 3? I'll buy it. Plus what?
Plus
just
2,
the 1
right?
gate.
2.
2 gates?
2.
There's 2 gates.
Yeah, 2 gate.
An AND gate
5.
here, and then an OR. So that's a cost of 6. So it would be foolish. I'm sorry, that's T1, not T0. It would be pretty foolish to use T flip-flop for flip-flop number 1, right?
Yeah.
Right. And T1 is even more foolish. 1 input
T0.
plus 4
T0,
literals.
you mean?
Yeah.
T0, the cost of that one is 1 input plus 4 literals. Oh my gosh, that's horrible.
It's 8.
Plus
3.
Yep. So, what's the best implementation, guys?
D0.
D0.
D0 for flip-flop 0.
Yeah.
And
and
Probably J1K1.
J1K1. Or D1 is the same.
Or yeah.
The cost is equal between D1 and J1K1.
Yeah.
And D1 is the simpler of the two to implement, so.
Well, you're frequently, if you've done the sequencer lab or taken, if you remember anything of the flip-flop lab or the sequencer lab, you should remember that flip-flops frequently come in pairs, do they not?
Yep.
Yeah.
So you can implement this entire mess, and it's not a mess, it's the sequencer. You can implement it with one chip plus what was D0?
D0 demanded
is here, just X. No gates, no gate here. And we need a 3-input AND gate here, and we're done. That's pretty cool, isn't it?
Mm-hmm.
Okay. If you understand this, you will be able to do the second half of the opportunity.
And that is just nothing but, from here on, it is the same thing as on the lab. It's just wiring things to the chip. And we already have them
Yes. Yeah. Yep.
Okay.
Okay.
So only the 6 hours.
6 hours, guys.
But
how long did it take us to go through this one? We went through this in a half an hour, guys.
Yeah, not even that. And we were doing it kind of slowly.
We go through it with you.
Yeah, I mean, yeah. One input.
D's and T's always have one input.
Yes.
And JK's always have two.
Okay, guys, I really have to get with Josh and Sam, so we're not up till 3 in
Thank
the morning.
you. Appreciate your review section, Professor.
Was about to say, it means the world to take all this time out of your night. We really appreciate it.
Yeah, really appreciate it.
I appreciate that you appreciate it, guys. A lot of classes. It's expected
One
of
question really
students.
quick.
Yeah.
The original thing that you wrote said implement least cost sequencer using one JK and either a D or T. So, but we just decided we were going to use 2 D.
Yeah, I should have said because I'm going to be honest with you. I didn't expect the second flip flop to be anything but a JK, because usually JKs have the least cost. So.
Okay. So basically, just change the question to define which 2 flip flops are the least cost.
Yes.
Okay.
But
all right.
But you can't. But you can't use 2 JKs. But in this case, it still wouldn't have mattered, would it?
No.
You wouldn't use 2 JKs because that has a higher cost of 2 Ds. Usually that doesn't happen, guys. But it did this time.
I have a quick question, not about the material, but about the opportunity itself.
Okay.
What time does the 6 hours open? Like, when will we be able to start taking the exam?
9:00 a.m.
In the morning? Okay.
Yeah. Yep.
Thank you.
Okay, guys. I really got to go.
Thank you so much. I really appreciate it.
Okay. Take care, guys. And good luck tomorrow. And whatever you do, if you run into trouble, you know what to do, right?
Yep.
Ask you.
The first thing you do is ask all of your classmates, right?
No.
Thank you. Thank you. All you got to do is ask. Okay?
Yes, Professor.
All right. It'll be on Blackboard. It'll be on Blackboard. That's why I got to get with Josh and Sam so we can get that set up for you.
Okay, cool. Thank you.
Yep.
All right.
Have a good day.
Take care, guys. Bye.